Hello everyone. Still continuing with DC circuits. Problem number one here on the left. What is the Thevenin equivalent? So Thevenin. Whenever we are asked to find Thevenin, it means two values: the voltage equivalent and the resistance equivalent. So Req and VEQ. So to find Req, we have to short circuit all the voltage sources and we have to open circuit all the current sources. So since here we're dealing with a current source, we have to open circuit it to find Req. So when we open circuit that, this is what we have left. When we open circuit this, we have this. It's open circuit, right? Okay, so there's nothing, pretty much there's no no current flowing because it's infinite resistance, and so we have 12 ohms and the RL is disconnected anyway. Okay, so this is A and this is B. Now since this is not connected with anything, the only thing that's left for between across the terminals A and B is only 12 ohms. This is not connected with anything. Is open, so we don't even count this 6 ohms at all. So Req is equal to 12 ohms. So do not even add these two, because remember we have an open circuit here. This is not connected with anything at all. There's an infinite resistance going here, and if you add infinite with anything, it's going to be infinite, right? So you can't even count them. So we have a infinite resistance going through here and then 0 amp. So that's why the 6 ohm is not counted. So do not even put them in parallel together. So the only thing we have left between across the terminals A and B is only 12 ohms. Okay. All right. So now to find the voltage equivalent, we have voltage is equal to what? Voltage is IR. So IR. So I is the current source was already given, because when you're finding the voltage equivalent, you have to put the source back. But when you are finding the R equivalent, you have to open circuit the current source. And if that was a voltage source, we have to short circuit it, like the problem on the right side. But we're gonna get there in a little bit. So now VEQ. So now I is the current source, which was 10 already, times Req is 12. So this is equal to 120 volt. So that's your Thevenin. Okay, so these are your Thevenin values. Alright, now problem 1.2 on the right side. Size the RL to allow maximum. Hold on, let me put. Okay, to allow maximum power transfer through A and B across here, over here. Okay, so now one thing we have to remember is that maximum power transfer occurs when the RL, the load resistance, equals the source resistance, meaning we have to find the Thevenin or Norton, but let's find the Thevenin EQ resistance for the circuit here. So Req, so RL would be equal to Req. Okay, so what's Req? To find Req, we have to short circuit the voltage sources or open circuit the current sources. So since here we are dealing with a voltage source, we have to short circuit it, not open circuit. So this is what we have. Short. When you short circuit, you have 0 resistance. So there is absolutely no resistance here, and you have infinite amp, infinite current. So you have your 10 here, your 15. So the voltage source is short circuited here. If it was open circuit, we wouldn't have anything here, like the problem 1.1. Okay, so RL is disconnected, and every time you're doing Thevenin, you disconnect the RL. Okay, so you have 2 here, you have 15, and then you have 10 here. Okay, so these two are in parallel because of the branch here. They're not in series, so these two are in parallel. So you have 10, 15 over 10 plus 15, and then the total is in series with 2, so you add the 2. Okay, so now you have 150 over 25 plus 2. So that's 150 over 25 plus 2. Let me get the calculator. So plus 2, that's 8. Oh, I should have known that. So that's 8 ohms. So RL is 8 ohms. That's it. Okay, next problem. Find current flowing through the 3 ohm resistor and find also the energy stored in the capacitor. So where's our 3 ohm resistor here? Okay. So find the current flowing through here. Okay. So notice that we have an inductor and we also have a capacitor. So whenever you have an inductor, that means it's a short circuit. So there's 0 resistance. And when you have a capacitor, it's open circuit. So when you have an open circuit, so this is what we have left over. Let's see, what's the voltage here? The voltage was 24, I think. Yeah. Okay, so now since this is a short circuit, this is a short circuit, 0 resistance, and this is open because of capacitor. So this is open circuit. Nothing flows through open circuits. No amp, no current. Okay, so now this is what we have. Six ohms and 3 ohms here, and still are 24 volts here. So you see how helpful that was to know that inductors, because otherwise you would have to go through a lot, because this will just give you a headache if you were trying to find, if you didn't know that rule. Well, it's not a rule, but it's like a basic thing to know. But if you if you skip that part, like if you kind of forget that, if you kind of forget to short circuit this and open circuit that, you will have a lot of problems. You'll spend a lot of time trying to figure that out. So this is much easier, right? So now we have that. All we need to do is just apply Ohm's law, right? So now we have what was the question? Find through the 3 ohms. Okay. So the current flowing through here is the same thing as this one, right? Same thing. So we can add these two as series as 9. And so we have V is equal to IR, and I is of course equal to V over R. So V is 24 and R is 3 plus 6. So that's 9. And so whatever our calculator gives us, 24 over 9, it's 2 point something. So that's 2.666, so almost 2.7. 7 amp. Okay, next problem. Compute the power delivered to the 6 ohm resistor. Where's our 6 ohm resistor? So the power here. What's power in the first place? So power is equal to I squared R. So we have R. R is 6 ohms, and we don't know what I is, right? So we have to find that out. So of course we have an inductor here, so this is going to be a short circuit, zero resistance, and this is an open circuit. Nothing flows through here, so it stops here. Nothing goes through that capacitor. Zero current goes through. So now you're left with a circuit that looks like this. Oops. Wait, okay. Plus, minus. Let's just put a value here, 12 volt. So you have this, and you have your 6 ohms. This is kind of like the previous problem. 18. But this is asking for power delivered. Okay, so the current is the same thing. So of course, VI is equal to V over R. So V is 12, R is the series here, so 24. So this is a 1/2 thing. 0.5 amps. And so of course we know everything now. We can calculate the power. So P is equal to 0.5 squared times R, which was a 6 because that's the question, right? So taking our calculator. Times 6, 1.5 watts. Power, that's it. Okay, next problem. Okay, so calculate Thevenin equivalent between points A and B. So again, Thevenin is REQ and VEQ. Okay, so to find REQ, we have to short circuit all the voltage sources and open circuit the current sources. So since we have a voltage source here, we have to short circuit it. We have 2 voltage sources actually, so we have to short circuit that and rewrite it, and then we don't consider, because the question here is between point A and B, and so we disconnect the 20 ohm resistor here. So this is the circuit. This is what the circuit looks like when we short circuit the voltage sources. So we have a so there's nothing here, so we have point A, and then we have point B here. Short circuit voltage sources. So Thevenin between A and B, so the voltage across A and B and the equivalent resistance. Okay, so 5 ohms here. We have a 10 here still, 5 here, and we have 10 here as well. Okay, so what do we have here? So these two, because of this particular okay, yeah, because I was wondering. So there's a line here, yeah. Okay, so now because of this, we have a parallel circuit here between 10 and 5, and also 5 and 10 are also parallel, so we have two parallels. And so these two together, that's parallel, and then they will be in series. So we have REQ would be these two, the 5 and the 10, they're in parallel. Let me do it this way. I think it would be a lot easier to understand because I'm working it in my head, but okay, let's do it this way. So we have 5 and 10, so that's 5, 10, 5 plus 10, so that's 50 over 15. This is this one right here, these two, this one and this one right here. And these two are also in parallel, so we have 10 and 5 over 10 plus 5, same thing, 50 over 15. So now they're going to be in series together, so we add them together, so that's 50 over 15 plus 50 over 15. I hope I'm not confusing you with the writing, but yeah, so okay, so now we have what do we have? So now we have 100 over 15. So this is 100 over 15, whatever that is. Let me calculate that. 6.67. What am I calculating? R, so that's ohms. Okay. So REQ, we're done with that. That's 6.67 ohms. So now we have to calculate VEQ. So going back to the original circuit, now we put the sources back. And so we have a current flowing through here. Let's call it I1. And we have a current flowing here. Let's call it I2. So it would be the same thing anyway here, but with the voltage sources. Okay, so remember this is disconnected, right? Between A and B is disconnected, and so we're trying to find VAB, the voltage across this A and B, these terminals, when the 20 ohm resistor is out. Okay, so first we have to find the so if we were to calculate it from here, from this particular circuit, okay, we would have KVL would be plus minus here. KVL would be minus VAB. That's what we're trying to find, minus VAB. Okay, this would be plus minus, and this would okay, so that's plus, from plus to minus, that's minus 5I. Okay, 5I2, this current here. Okay, and from minus to plus, that's positive, so that's plus 10, and that would be the current over here, I1. Let me just put I1 here, I1, and I2 here, plus I2, that's equal to 0. And now all we need to do is find I1, I'm sorry, that's I1 here, not I2. That's a different loop. Okay, so this is I1 over here. So all we need to do is just find I2 and I1. Whoa, This is 1. Sorry. Excuse me. I put I. Okay, so this is 1. Okay, not I. Alright, so what's I1? So that would be I1 is, remember we have a voltage here, so I1 would be 20 over 5, right? I mean over 15, I'm sorry, over 15, these two. Okay, so I1 is equal to 20 . I feel like I spent so much time in this particular problem. Okay, so 20 over 10 plus 5, that's 15 amps. And I2, what's I2? I2 is also 20 over 15. Okay. So all we need to do is just replace them and find VAB. So VAB is eventually 5I2, 520 over 15 minus 10, 20 over 15. So this whole thing, let me see. Minus 10. So I have 6.67. 6.67 volt. So our VEQ is equal to 6.67 as well. So that's it for Thevenin. So always you could start with R's. You could start finding the equivalent resistance and then find your voltage. So for the resistance, again, you have to short circuit your voltage sources and open circuit your current sources. And then after that, you put it back. Whatever the load is or whatever the question is between that point, you disconnect that. So that's not part of it. In this particular case, it was the 20 ohm. So you don't include that one at all. And to find a V, you just follow through with your KVL and your KCL to find VEQ. And that's it for Thevenin. Alright, so we'll continue again with other problems within DC circuits, and then eventually AC circuits, and then op amps, etc. Okay, thanks.